let's see. So where last we left our intrepid explorers, they were trying to get some crap to work. So, all right, here's where we're at. We've got session manager. We have this instance, and now there are a couple things that some caveats emptor. So for one, it is possible this isn't going to work because I just picked this AMI at random. This is actually the AWS AMI because AWS has their own operating system that they make available. So that's a problem or it could be a problem. And then two, I haven't checked in a while to make sure that we can get out. So there may be some additional routing chicanery that I need to go through in order to make some things work. So, there is that. In fact, I'm pretty confident now that I'm thinking about it, that there's going to be some routing silliness that I need to do to make this work. And I'll kind of talk about that when I do it. It's not really related to the key thing, which is making this guy talks to GitLab, other than it's just a networking thing. And I'll talk about why some of that exists and why we're having to do it. So right now we're going to go ahead and connect in Session Manager. Okay, and we're on our command prompt. So I want to ping Google to see if I can get out, and I can't. All right, I think I know why I can't get out. So if we look at our architecture here, we have all these routes on this side that send, and I'll verify this. Actually, I'll verify it right now. Networking. Interfaces. Where is the... I'm looking for the route table. I thought it was under networking. Maybe I just missed it. Let me go back. All right. Subnet. Oh, it'll be under the subnet. So, all right. Route table. Here we go. All right. So basically what this says is that anything that's related to the cluster goes to this endpoint. That's how you can read this. And then all other traffic goes to the transit gateway, which is what we want, and any internal traffic for this VPC stays local. So yeah, that's exactly what we want. So looking at our map here, basically our route tables for this entire VPC send any northbound traffic, any quote-unquote internet-bound traffic to the transit gateway. So all these guys send here. That's what we want. And now if we go and look at that transit gateway, it's going to have a route table. And this route table basically says anything that is 192.168 bound goes one way. Anything that's 10 bound, which is the boundary VPC, or anything that is quad zeros or any internet traffic is going the other way. So basically our transit gateway also says, hey, anything EKS goes this way, anything otherwise goes that way. So we're good there. So now let's go check our boundary VPC. And this is where I'm pretty confident that's where the problem is. So if we come in here and look at our boundary VPC, we actually have two different networks, or two different subnets, and each of these are using separate routing tables. So if we look at this routing table, for instance, it says, hey, anything 1016 is local, anything 168 blah 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 goes to the transit gateway. Let's look at the other routing table. This guy says, hey, anything that is internet bound goes to this target, the internet gateway. Anything that's 10 is local, and anything that is whatever goes to the transit gateway. So basically the problem that we have here is, and you can see this in the architecture drawing, so even though I don't have it connected, each one of these subnets, or don't show it as connected, each one of these subnets has their own transit gateway attachment, but that's not true of the boundary. And the boundary, this private subnet down here, the southbound one, has, let me make this bigger. This southbound subnet here, it has the attachment. The northbound has the internet gateway, but this guy doesn't have a route telling him to go this way. And this guy, even though he has a route telling his traffic to go this way, I'm not entirely sure that's working. And I'm not going to explore it too much. The reason being that AWS has a bunch of Mickey Mouse silliness that happens behind the scenes with respect to how the VPC network traffic works. It's not what you think. It's not. Just as a general rule, you can think about a VPC as being a VLAN. It behaves very, very similar to a VLAN, where a VLAN is a logical separation between traffic. So, like operations VPC and boundary VPC cannot see each other traffic-wise unless they go through a router. Same exact way VLANs can't see each other unless they go through a router. The difference is that in a normal VLAN, if you have like VLAN A and then you have subnets 1, 2, and 3, well, subnets 1, 2, and 3 may not be able to see each other because networking wise they are separated kind of a little bit logically like that. But if you were to put like a system in the inspection subnet and set the interface to promiscuous so it sees all network traffic, it will see all network traffic for all the subnets around it because they're all in that same VLAN. So all that traffic is floating around in here. And that means that, like, if you specify a route on something and tell it that, it can go over here, like southbound knows about northbound, it can reach out and talk to northbound, and that works. Now, what you've probably may or maybe didn't notice is that both of these tables had something here that said, hey, anything in this subnet or anything in this VPC is local. That means that routing is not necessary. All these guys, even though they're in separate subnets, they all still see each other. They're all still there. So, really the subnets inside the VPC from a traffic control standpoint don't really make a whole lot of sense. And that's not even getting into some other silliness I've noticed over the years between how these operate. So it's just one of these things that it's a little black box, and that means that it changes sometimes and you're not entirely sure because it's happening behind the scenes. So what I know from last year may not be true now, but it does mean that sometimes if you have really, really weird problems, you just need to be aware of the fact that there is some black box magic happening behind what you're seeing, and that can affect the way traffic flows through here. So long story short, all that was background. What I'm going to do right here to try to solve our problem immediately is it is possible I can put a route in this subnet that tells it all northbound traffic needs to go to, the internet gateway up here. And it might work because it is in this VPC. It might actually see that boundary gateway. Now, the way I've had to do this in the past was a little bit different. And in that case, I had to set northbound subnet where all the internet traffic landed. I had to tell it any southbound network traffic needed to go to the southbound subnet. And then in the southbound subnet, I had to make another rule that said any internet bound or any external bound traffic had to go to the northbound subnet. So I basically had to create routes between these two subnets to connect them. And that's why there's actually this firewall that will eventually be here. And those same rules will get changed so that northbound from here goes into the firewall, southbound from here goes into the firewall, and that way we've got that in the in between the two. But for right now, I might be able to just go straight to the gateway. So let's give that a shot and see what happens. So this is the other table. Let me edit routes, and we're going to add a route for Quad Zulus. And it's going to go to Internet Gateway. There is only the one. Save changes. All right. Now we have done that. Let's go ahead and see. It might even take a little bit to update. So we'll try it. It doesn't work. All right, so we're going to give it, let's see, it's 9:59. I'm going to give it about 10 minutes for these routes to propagate. It may not solve the problem, but we're going to give it a shot and see what happens. So I'm going to go ahead and kick it over into standby real quick and start the music again. And then in about 10 minutes, we'll come back and do another ping and see what happens. That's probably close enough. All right. Still not working. Okay. So here we are trying to ping something. Let's do a. Okay. So here's the issue. So we're not getting through. I think what we probably need to do is change the way some of these routes are going. Let me see if I can do that easily. I don't know if I can. Not entirely sure that. Okay. What I might have to do is rearrange. That should still talk though. Okay, so it is attached to VPC. So this guy should be seeable by everybody. So even the private subnet should be able to reach through and get to this guy. You know what? I bet I know what the problem is. Let's look at boundary. So I think it might be a security group problem, because our security groups here in this VPC probably do not allow traffic inbound. I don't know what that was, but I hope nobody died. Yeah, okay. So let's say we're going to allow all traffic from, let me double check, what is 192.168? So allow all northbound traffic. And then let's also check outbound. So we also want to allow outbound. Allow all traffic going anywhere to get out. Okay, so that is that. All right. Now let's try this again. Still 9. Okay. So one of the issues I do have with AWS on occasion is just the fact that sometimes it really does take quite a while for these networks to update. So I'll continue troubleshooting, but it is entirely possible that I'm causing problems for myself, because usually when I'm troubleshooting AWS, I like to make a change and then live with it for about 5 minutes or so before I test it. Just because some of these changes take a while to take effect. Let's see. While I'm doing that, and here's some other things we can do. Actually, let's do a couple other troubleshooting where we kind of wait for this. I'm going to launch a new instance, and I'm going to put it in test boundary private. I'm going to create a couple new instances. I'm going to throw them in there just for testing. So this one we don't need key pair because we're going to use SSL. Network settings. We're going to put it in the boundary VPC, and this one we call private. So we're going to load it into the private subnet. We are going to use the default VPC. And then advanced details, we're going to have it use this same runner. Actually, you know what? Let's use the test profile I created the other day, and we'll have to go through and delete that here later. So let's launch that instance. Now, while that's happening, another thing I know we need to do is create some endpoints for that VPC. So let's create, and we're going to call these just B's. They're easy to find them later. And we're going to put that because this boundary VPC also does not have these endpoints. So really, we'll put it in the southbound. Okay. And update that security group, then endpoint. And then we need to add, and this would be blank, messages, boundary, southbound, security group, go. And create. Okay. Wait for these guys to come up. So what I'm doing here is I'm going to, I'm basically creating an instance that's in the boundary. I'm going to create an instance that is right here, and I'm going to connect to it, and I'm going to make sure this instance can get to the internet. So like if I know I can get to the internet from here, then I'm going to turn around and try to get back to the router itself from here. And so there may be some additional security group rules or something like that that needs to be updated. So we'll try it in both directions. Like this runner should be able to ping this guy. This guy probably can't ping the runner right now, but we'll turn around and check that. And then, yeah. So endpoints. Still pending. All right. One's online. These other two are pending. I need to make like a like and subscribe kind of thing. That'd be pretty funny. All right. Okay, now we're all available. The instance was launched, and there it is. Okay, so test boundary private. So you should be able to connect to this guy. Oh, is he still coming up? No, it says he's running, isn't it? I bet there's probably one of those endpoints I need to add that I had forgotten about. All right, let's look at our endpoints here. ECR, SSM messages, EC2. I don't have EC2 messages. Maybe I need that. Let's go ahead and add it just in case. let's just check. Southbound, southbound, southbound. Okay, all these guys are southbound. And this is the one we're waiting on. And security groups. Basically. That doesn't look right. Oh, okay. Because I need to drag it down. All right, let's see. Boundary default VPC. Outbound to anything is fine. Inbound from anything is fine. Oh, wait. Okay. So edit inbound rules. So we do want to allow all traffic to, can I do an endpoint? Nope. Oh, anything in that security group. I think that's basically how that one's written. And you know what? While I'm doing that, I'm probably not going to add a role. I just want to look and see what else. You know what? Let's throw that guy in there anyway. All right. Now let's go back to instances, connect. All right, let's restart that guy. Reboot instance. Okay. All right, let's think here. What all did we have to do to make the other one work? We had a bunch of endpoints, which we created. We needed the IAM role. Let's just check the role. Test SSN role. Let's put it on this one for now, just check. All right. He's back up, connect. Oh, I don't know if it was the reboot or if it was changing the role, but we can talk to him now. All right. So now what we can do is ping 8.8.8. That is not getting out. So what about curl? Do we have curl? Okay. Curl dash K. All right. And while we're doing that, let's see. I should be able to ping this guy. So let's try that. Oops. Oh, I can't paste. Oh, I can. Okay. There we go. So not getting out that way, which is not a problem. Let's see if our runner can ping the other way. Okay. Ping. Okay. So what's happening is our runner is able to get to us. Let's just, oops. Okay, just make sure. All right. So our runner is able to get to our system. So let's look at this. So basically, this runner is able to get to our test system here. So this direction works. This guy is not able to get back to here. All right, so that direction is not working. Let's go over here and check default operations. And if I pull this up, actually, let's just edit them. All right, so I have TCP, custom TCP from here, SSH from here. So ICMP from 10 should work. So I should be able to go back that direction. Okay. And SSH obviously is allowed from 10. All right. So I see no reason why this should not work. Let's. Oh, but you know what? Let's go look at that instance and see what it says its security is. Okay, security. All right. So according to this guy, inbound rules, anything from this security group. Okay, so it only has the cluster security group. Let's check it. All right, I bet this might be the problem. Or at least a problem. Let's look at outbound. Okay, let's edit the inbound rules real quick. We're just going to add a rule that allows all traffic from 10.0.0.0/16, which is our public side. Let me save that real quick. And then let's try ping again. Okay, so we've solved that. So now we know we can get from here to there. Now what we're not able to do is to get from here to Google. All right. So let's check that. All right. Security groups. All right. So looking at it on the chart, so we can get from here to here, and we can get from here to here. So we know all the way to this point we're good. So we need to find out is routing wise, security group wise, are we allowed to go out? So let's check security groups first. In fact, let's do this by checking our instance, and we'll start here. Okay. So security groups. Excuse me. Inbound rules. We are allowed in from here. We're allowed anything from the security group. Out, we're allowed to do anything going out. So security group wise, there isn't anything here that should be blocking us. Let's check. Oh, you know what? Let's try this. If we go to internet gateways. This is the internet gateway. But it's not giving us an IP address. Well, you know what? Let's so southbound routes. Let's look at these guys. All right. So everything should be going to the internet gateway. It is associated with that subnet. Yorkbound. Okay, routes. Let's try this. Let's create this one is going to also be in the boundary, but it will be on the northbound side. And we will use the default security group. Sorry, I don't know what's going on in my throat right now. And we're going to go ahead and use this runner for now, or this profile for now, just in case that was the issue. All right, we'll give it a little bit for that to come up. Yeah, one thing is when I created those endpoints, I did create them on the private side. I did not create them in the public side. So, of course, they may not be needed on the public side because it has the Internet Gateway. Been talking too much. Usually I come in here and go to my zone and just piddle around until I get it working. I don't normally talk to people while I'm doing it, so I think my voice might be going. Oh, this is one thing I do not like about Amazon's system. You know, they have this thing that scrolls even though there's nowhere to scroll to. And this frame should be over that frame, so this should only scroll if there's something to scroll to. Oh, I guess that works if you keep this smaller, but then that thing is too small. Yeah, their web UI needs some work. Still initializing. Come on. Loser. Well, let's see if we can ping it real quick. Okay. So now we know we can get from here to here. So this is working. Actually, let's look at our access control list. Inbound, allow all, allow all. Okay, well, ACLs aren't exactly doing anything, are they? All right. Oh well. Okay, so now it's up. Let's see if we can connect. And we can. All right. Can this guy ping out? He cannot. All right, so we're getting somewhere. All right. So basically, he now exists here in this northbound subnet. There is an internet gateway there, and that internet gateway should be allowing traffic in and out, and it's not. So what are we missing? Well, let's go look over here. All right. So we have an internet gateway. It is attached. Oh, you know what? I bet what we need is a NAT gateway. Let's test that real quick. Okay, that is what we want. All right. Now, let's go make some route table changes and see if that makes a difference. Nope. All right. So we are getting somewhere. All right. I don't think this is necessary. I think Internet Gateway is what we actually needed. I don't think. Oh, NAT Gateway ARN. Oh, well, it's still pending, so we probably can't do anything until it's ready anyway, but we could test pinging it. Which may not work because I don't know how they set these things up. So, okay. Okay, it's available now. So it's possible that we can't ping it because I don't know for sure how AWS sets these things up. But if anything, would have. This is our public one, so it should have been able to. Let's try pinging out again. Still no go. Okay. So. I'm really confident this isn't necessary. The Internet Gateway should be the only one we need. So what could be the problem? Because the Internet Gateway is associated with the northbound subnet. We have an EC2 instance in that subnet that cannot get out. Security group wise, inbound, outbound is allowed. Inbound shouldn't matter because it is a well, you know what, let's just open it up anyway. But the security groups are stateful, so you only need to specify what should be allowed to initiate traffic, not necessarily everything. But we'll go ahead and make that available anyway. All right. Okay, I didn't think so. And by the way, the reason I'm not leaving these pinging is because AWS, one of the weird things that's happening behind the scenes is there's some sort of like little session thing that gets set up. And so, like, if you start a ping and it's not allowed for whatever reason and you continue to ping, it will basically loop all that in the same session. And since that session has been denied already, it will stay denied. So you can literally be in a session, in a situation where from the same box, let's say you use Tbox or something to create multiple terminals, and you start a ping and then you change the security group. The original ping that you started isn't allowed. Then you change the security group to allow it while that original ping is still going. That original ping will will continue to fail. On the other side, if you ping again, and I'm not 100% certain if this would work, but it's kind of sort of what happens. So start the ping, fails, change your security group, do another ping while the other ping is still going, and you could be in a situation where the original ping is in a session that is blocked and will continue to fail. And then actually, let me change it a little bit. Let's say you have two EC2 instances, because I know that'll work. So two EC2 instances, you can attempt to ping from both of them, and it fails. Start a ping session on one so that it continues to ping. Change your security group so that should be allowed. The original ping that's continuing will continue to fail because that session, for whatever reason, is blocked. Give it a couple seconds or minutes, and then try it on the second EC2 instance, pinging the exact same thing, and the second EC2 instance will work because it's a new session, and that new session checks the security groups to make sure that it's allowed and everything before it goes. It's really, really weird. I don't know. It has to do with the black magic that happens behind the scenes, but the point of it is that those of us who use Linux a lot tend to initiate a ping and just leave it running in the background while we're making network changes, because the moment that you get the network correct, you see the ping suddenly start going through. That is not the case for AWS. So you've got to start the ping and then stop the ping, and then do your changes, and then come back and start the ping and stop the ping. I spent a lot of time pointing it out, but that's basically what I wanted to point out. All right, this is not making sense at all to me. There is no reason that these guys should not be able to get out. Okay, so here's what I'm going to do. I'm going to go to the NAT gateway. Well, actually, let me go back to those routes first. So I'm going to fix these routes so that they're back the way they should have been. And this is Internet Gateway. Boom. And then edit routes. Internet Gateway. Boom. All right. So both of those are the way they should have been. Let me go to the NAT Gateway and get rid of this guy because that is not necessary. All right. Okay, so the question is, why can I not get out here? Inbound rules are fine. Outbound rules are fine. Just double checking. Yeah. Okay. This is an odd question. Very, very odd. You know what? Let me try creating another gateway. going to attach to, operations. No, we don't want that. All right, here's what we do. Boundary, actions, detach. Test, actions, attach, boundary. Okay. Route tables. Okay, those should be updated. All right. Let me check, see where when my next meeting is. Okay. All right, it's at noon. I do want to go eat lunch, but I guess do a little bit more time. All right. All right, let's do some Googling. Well, let's give that a shot. Okay, what we just did is, another weird thing about AWS is that it has, that may not have been exactly what I wanted to do. Oh, actually, that's fine because it was allocated to the NAT gateway that is now gone, so never mind. That was, oh, yeah. So actually, that one I can get rid of. So basically the way AWS works is they have public IP addresses. Think of them like sort of instant NAT, I guess, if you would, or instant port forwarding, or I guess IP forwarding. So PAT, no. NAT, it is NAT. Okay. Anyway, what ends up happening is you'll have like a public IP address that you could lease from Amazon, and then you associate that IP address with a specific target. In this case, an instance, And so anything you do talking to this IP address should go to this target. So for instance, let me copy this guy. So I should be able to this might not work, but notionally I should be able to ping that and it gets through. So that worked. All right. I wonder. Mother pucker. All right. So the network to get out and get back. That makes me think that maybe I do need a NAT, and that northbound traffic should be forwarded to the NAT. Interesting. That is not how I thought that would work. That doesn't make sense to me, because if that's the case, why would you ever need an internet gateway? But maybe that is the case. Maybe you need to have... No, that doesn't make any sense. Just for SNGs. Okay. All right. Well, let's back this up and let me try a couple other things. So I'm going to disassociate that elastic IP address. I'm going to associate it with the private here. Okay, so if that's the case, then this is the private one. That works. All right. Okay. Is not attached to any internet gateway. All right. So that makes me think the right answer is probably a NAT. Oh, let me. Okay, it's not associated, so. I'm gonna have to do some looking. I wanted to think about this for a little bit because this almost acts like I would need the NAT on the operations side, and then that would be the stand-in or I would direct all my traffic here to the NAT, which all right, let me go set up these routes real quick. And so that would go to the NAT gateway. And just because I want to see if I go to Transit Gateway route tables, there's only let's just see if, yeah, it's got to be an attachment. Okay, that's what I thought. Let me check one other thing. Transit Gateway attachments. And the VPC I'm looking for is F21. F21, so it would be this attachment. All right, I'm gonna have to do some reading because this is not exactly the way that I thought it should work. So basically, I was under the impression that as long as I pointed going out, as long as I pointed at the gateway, I was good. I'm pretty confident that that's right too. So yeah. All right. Hey, everybody, thanks for tuning in and watching me fumble around and screw this up. So it's been an hour of me not accomplishing anything. That's exciting, I'm sure. Anyway, I've got some meetings going on this afternoon. I'm not sure when I will get back to it, or if I'll get back to it this afternoon at all. If I don't, then tomorrow morning, more of the same. I think what I'll probably do is read through some articles this afternoon, just to make sure that, like, topology wise, I'm not crazy, because I am pretty confident that I'm really confident that, like, I've built these plenty of times in the past, and I've never had. In fact, I've built them exactly like this, and I don't remember ever having to do anything other than an internet gateway. So, but the fact that I can assign that elastic IP and it goes through, I mean, that sure makes me think I was wrong. But yeah, we'll play around with it and see what happens. Anyway, so thanks, and I'll maybe see you guys after lunch or not. If I send an email, you'll know.
Nam